All right. So we'll give folks just, well, actually, we're 5 after, so we might as well get started. I know a few folks will come in late. So this is the FHIR documents session. So make sure that's what you're actually here for. It's a pretty good crowd for that. So welcome all. My name's Rick Geimer. I'm with Lantana Consulting Group. We're a professional services company, do a lot of work with the U.S. government, CMS, CDC, and such, and also develop a lot of implementation guides through HL7. I'm also one of the co-chairs of the FHIR Infrastructure Working Group at HL7. I'm also on the CDA management group there. Developed a lot of implementation guides and leading the C-CDA on FHIR project, which is one of the things I'll be talking about today. And hang on one second. For some reason, it looks like, yeah, a couple of my, oh, there we go. Sorry, just I had a slide out of order. Apologies there. Let me fix this. C-CDA FHIR documents. There we go. Okay, sorry about that. That's what happens when you finish your presentation in the morning before you finish your coffee. Okay, so as we get started, one of the first things I want to do is orient folks a little bit to the concept of clinical documents. Clinical documents, anybody who's healthcare provider, if you've been through medical school, you kind of get a concept of what clinical documents are pretty quickly. You're trained to do them, to produce things like history and physicals, discharge summaries, things like that. But they all have some key characteristics that differentiate them from things like messages. So if you're a software developer, you might not quite understand the difference between a document and a message. But these are some of the key things that will differentiate them. First of all, clinical documents have this concept of persistence. They often have a legal retention period. So when you create a document, especially something that gets signed by a clinician, you're often required to keep it for a period of, say, maybe 7 years or so. So they're not something ephemeral that you just create and then send from system to system and then they go away. They actually need to be persisted. If you're going to persist something, then there needs to be some organization that is charged with that persistence, with holding onto a copy of it. That's often called the steward or custodian of that document. So that's where that concept of stewardship comes in. Next up is the potential for authentication or attestation. Clinical documents are meant to be signed by the providers that are creating them. And it's that signature on it that often actually is probably the key differentiating characteristic between a message and a document. Anything that carries a clinician's signature, that's a pretty good indication that it is a document or something that should at least be persisted and not just thrown away. Next is context. A clinical document will establish the context for everything that follows it. This is usually done in what's called a header, and that's where you'll have things like, what kind of document is this? Is this a procedure note? Is this a summarization of episode note? What date it was created, who the author of the document is, who the patient is, all that type of stuff provides context for everything that follows. Next part is wholeness. A clinical document will tell a whole story. It won't just be a single data element like what's a person's blood pressure. It's not a response to a query. Rather, it tells a whole story like an encounter note, everything that goes on in a particular encounter, or a surgical note, everything that happened during a particular procedure. So all that stuff is part of that wholeness aspect. So it'll tell a whole story that has occurred. And then lastly is human readability. Clinical documents, while they most of them contain a lot of computable information as well, they always need to be able to be brought up and viewed by a human. Because what you'll find is, while a lot of software developers, they care a lot about the coded data that's sent around between system to system, when you talk to providers, what they feel is often the most important part of the clinical record are the words that were actually written down by one of their colleagues, so they can actually see what's really going on with this patient, not just what got exported from an EHR by some program. They will actually want to hear or read what one human is saying to another. So that human readability aspect, not only to be able to bring up and sort of read what might have been written by a person, but also clinicians typically don't want to read SNOMED codes and figure out what they are, or LINC codes. They want to see the words that are actually behind them. And it's those words, that human readable part, when you bring up a clinical document and present it to a person on screen, those are the parts that they're actually attesting to. So when they sign a document, they're actually signing that human readable portion of it. And lastly, human readability is just it's a patient safety issue. Imagine you're a very advanced, high-tech EHR, and you export this document with, this SNOMED, ARCS, NORM, LINK codes, and all this other very valuable terminology, but you send it maybe around the world to somebody who's in a developing country, and they don't have that kind of sophistication behind their processing. The most they can do is double-click on it and bring up on screen and read it. If they can do that, they can still manage and treat that patient, and they can still provide care. If that human readability was not there, they would be lost. They wouldn't really know what to do. So having that ability to have it human readable but also computer processable is key for not only advancing the state of healthcare IT, but also providing a fallback when the technology isn't quite as advanced as you might hope it would be. So why are documents important? Well, as you might have gotten, there's a dual aspect of the clinical record. There's the data, which drives applications and processing and clinical decision support and things like that. And then there's the narrative, which again are those words that you're going to be explaining from human to human. And that duality is key for when you've got systems that are spread across different disciplines and different levels of technical sophistication, and having the ability to mix those in a single format is really important. So a little bit of history. So the granddaddy of clinical document standards is called Clinical Document Architecture, or CDA as it's known. It's been cited in federal regulation for quite a few years now, especially something called Consolidated CDA, which I'll talk about shortly. But CDA itself, it's a HL7 standard. It's based on HL7 version 3. It's not FHIR. It's also an ANSI and an ISO standard as well, and it was used to create a lot of implementation guides that are still in use today for things like Consolidated CDA. There's also quality reporting document architecture if anybody does quality reporting to CMS and other organizations. It's used by the CDC for healthcare-associated infection reports and also electronic case reporting. So there's a wide variety of standards that CDA was used to create. Consolidated CDA is probably the most easily recognizable one, because that was cited in what used to be the meaningful use regulations and is now called promoting interoperability. And it defined what were basically some of the most common document types that were in use, or rather, a lot of these came out of transcription, basically, where we were trying to codify things that were often dictated notes and just narrative only. We want to provide an avenue for getting those into computable form and adding coding along with it. Many of these document types were actually balloted as their own separate standards back in the day, and they weren't necessarily harmonized. They didn't really work well together. So there was an effort made to combine them into one implementation guide, harmonize the way that things were represented. So when you talked about an allergy in a history and physical, or vital signs on history and physical, it was done the same way as you would in a C-CDA. And so that harmonization and consolidation became what's called the Consolidated CDA specification. And that's evolved. It's been through several versions. It's up to 2.1 right now. So all that's been in use for a while. So why move off if it's in use and it's working? Well, I'll say one word: FHIR. CDA is is based on an older version of an HL7 standard called HL7 version 3. And aside from CDA, a lot of version 3 didn't really take off, especially in the US. It is in use in other parts of Europe and such, and there's a bit of version 3 use in the US aside from CDA, but really not much. So one of the goals that we wanted to do as we were starting to work with FHIR is how do we take the knowledge and everything that was created in those CDA standards and Consolidated CDA and others, and how do we take those and make them work with the better syntax and APIs and such that are available on FHIR. And so one of the things we had to do was sort of compare what the similarities and differences were between FHIR and CDA. And so it helps to understand this. Both standards, for instance, support profiling for specific use cases. In CDA, we call that templating, and in FHIR, it's called profiling, and that's where you'll take a certain thing and constrain it for a specific use case, such as for use in the U.S., where we're going to say we're going to use these codes here in the U.S., but other countries might make different choices. Both FHIR and CDA have that human readability as that minimum level of interoperability. CDA sort of came up with that paradigm, and then FHIR looked at it and adopted it across all FHIR resources. So every FHIR resource has the ability to have a human readable chunk of HTML in it, so you can display it to a user. Both FHIR and CDA have validation and profile tooling available. However, in CDA, this was an afterthought. In other words, we started creating implementation guides in CDA. Well, the CDA release 2, the one that's in use, was created in 2005. And all the tooling that came along with that really happened after the fact. The first CDA implementation guides were often created in Microsoft Word documents. And then later on, we created profiling where we can click and constrain stuff and generate validation and documentation out of the same tools. But that, with FHIR, from day one, that was pretty much available. And you'll see that tight integration of tooling with the base standard in FHIR. Some other key differences about FHIR, though, is it's out of the box usable. And not that you necessarily should use it without doing profiling, but it's already got key concepts defined as part of the FHIR resources. So you've got, for instance, an allergy and tolerance resource. You've got observation resources. You've got encounter resources. CDA didn't really have that level of granularity already defined out of the box. So for CDA, if you want to represent an allergy, you need to actually create a profile just to define that basic concept. Whereas in FHIR, those basic concepts are already well defined. FHIR also is not restricted to just documents. So CDA was a standard, and it's got it in the name, clinical document architecture. But a lot of people tried to use it because at the time there was only one thing to use, so they would use it for a lot of other use cases where a document didn't really apply. They almost tried to use it like a message. So FHIR, it's not restricted to just documents, so out of the box you can use it for all these other use cases. You don't really have to abuse the document paradigm if you want to do a big EHR to EHR data dump, which is pretty much what the C-CD document type kind of resulted in being. The specification and implementer tooling is generated together. So when you generate the FHIR spec, you also get a lot of code generation that goes along with it. So there's much tighter coupling of the reference implementations to the spec itself. And also, it's got the REST API built in out of the box. Whereas CDA never had an API along with it that was baked into the standard. Organizations like IHE came along afterwards and built a lot of infrastructure around that, but it was never really tightly coupled to the spec, whereas in FHIR that is the case. Okay, so FHIR documents. So FHIR has a variety of paradigms in there. One of them is the document paradigm, and it really is meant to address the CDA use case for clinical documents, as well as provide a mechanism to do generic documents. So one thing about FHIR documents is they don't need to be specific about patients. You can have a FHIR document that is an orderable catalog of parts, for instance, whereas that would not have been appropriate for a CDA, which is a clinical document meant to be about a patient. So it is a little bit broader, but it does address the CDA use case. FHIR documents are generally a collection of resources that are bound together. The main resource is what's called the composition resource, and that provides the context, which is one of those key characteristics. Tells you who the patient is, who the author of the document is, what kind of document it is, when it was created, if there's any associated encounters or things that are with it. Those are all bound in the composition resource. And that composition resource also contains the human readable narrative. So it's really one-stop shopping for all that contextual information and what the clinician is going to sign or attest to. And then it can also have a variety of other resources with it. So you can have coded allergies, encounters, conditions, all that can be linked into there and tightly associated with the sections of that document. When you take that and you want to send it from a system to system, though, what you'll do is you'll create a bundle resource, and bundle is another resource type, which you can use to sort of collect a variety of resources together as a single whole. You can also sign it and attest it. And there is a special bundle type called a document bundle, and you would basically put all those resources together in a document bundle and then send it along. So FHIR documents have the ability to sign them and attest to them, just like CDA documents. But they're actually easier to also, when I say sign, I mean record the name of the person who is taking legal responsibility for this. But you can also do digital signatures if you want to verify that something's hasn't been altered, for non-repeatability and such. The same core principles that I listed on that very first slide about persistence, potential for authentication, all that apply with FHIR documents. So nothing really changes there. The main thing that's changed is the syntax that you use and that tighter coupling to APIs. So I guess the point I'm trying to make is that FHIR documents address that same use case but make things a lot simpler and easier, especially for new implementers. So the full rules for FHIR documents are here. I'm pointing to the current build of FHIR, just in case you want to see the latest and greatest. But there is a documents page. If you just go to hl7.org/FHIR, there's a page that describes documents as part of the published version of the standard. So I mentioned bundling. So the way that bundles work basically is you've got a bundle resource that wraps a variety of other resources. So in this case, we've got a composition resource that contains all that contextual metadata about a document. It contains a series of sections. Sections in the composition resource can nest, so you can have a section that has a subsection. Basically just like any other type of document when you're flipping through paper, you can see that type of thing. It has the ability to hold the attester, the person that's signing the document as well. And then in these sections, you've got references to other resources, such as medication requests for prescriptions, observations, devices, the patient resource itself. So all those are referenced from the composition resource. And when you put these together and you bundle them, what you end up with is a bundle resource with a series of entries. And each of those entries can contain references to other ones. And the idea is you want to, in that bundle, you want to have all the references, basically what we would call the transitive closure of all them. So you want to have everything that's referenced in that document present in that bundle. And that's very important because of that first criteria for documents, that persistence one. Now I mentioned earlier that the legal retention period for documents is often 7 years. How long has FHIR been around? Not that long. How many FHIR servers last for 7 years? Not many. So documents often outlive the systems and in many cases the standards on which they're created. So having the ability to have everything that was referenced in that document present and archivable and retrievable later is very important to meet legal requirements, whatever your jurisdictions require, be it 7 years, 10 years, or what. So that bundle really satisfies that need. You can capture everything, wrap it up tightly, sign it, digitally sign it if you want, and then archive it in whatever you want. You can do that on a FHIR server, you can put it in a document management system, some other type of clinical data repository, and keep it there. And 5 years down the line, when maybe FHIR is on release 6 or whatever, and the FHIR servers that you created this on are long gone, you can still pull that out and retrieve it and be able to trace all the references and get all the data that you wanted that was in there. So the composition resource, as I mentioned before, it sets that context. It has things like the patient, the author, the custodian, all that information. It's basically sufficient for medical records management, document management, and such. I like to think of it as a index into the document as a whole. It's got all that information that you want to be able to search on, and the composition resource actually has a lot of search parameters that let you go in there and say, I want to find all composition resources about this particular patient, or I want to find all discharge summaries. So you can do searches and retrieve that information back very easily. So it's a very useful indexing mechanism. As I mentioned, the composition resource has sections, and those sections contain narrative. So the sections in there, again, can be nested, so you can have sections within sections. The narrative markup in FHIR is XHTML, or rather a simplified version of it. We don't allow active content, so no JavaScript or any of that type of stuff in there. It's almost like a HTML from the golden age of HTML, like around the year 2000 or so. So not very fancy and dynamic, but it does contain all the information that you need. That's a difference from CDA. So CDA actually had its own narrative markup that you'd have to convert to HTML. So this is a little bit easier to display and to author as well. The narrative contains the attested text of the document. So again, when a clinician signs a clinical document, they're signing that attested text, not the codes that are behind the scenes in the other resources. And it is perfectly fine for sections to consist of only human-readable text. So you don't need coded data in order to make a clinical document. It's a valid use case to be able to send narrative-only documents. Okay, here's basically how a section looks like in FHIR. I'm showing the XML representation of it because I'm an old-school XML guy. Sorry, JSON folks. But a section basically will consist of a title. In this case, the title is allergy and intolerances. And then you'll have a code usually associated with that section, which will tell you what kind of section it is. That is optional, but usually I would say most sections do present them. So this is a LOINC code that represents allergies and adverse reactions. Next, you've got that human readable narrative block. So if you see, this is actually in the XHTML namespace, and I've just got a simple unordered list that has a single item in it right now, penicillin-hives. Now, when you take this and you bring it up and render it on screen, there's a very simple style sheet that's included with the FHIR spec for rendering documents, and it'll just take the titles and make them big and bold on the top, and then it'll render the HTML just as it is. So it'll render this as an unordered list. And you'll see on the screen allergy intolerances and then penicillin-hives. As a human, you would look at this and interpret that, oh, if you give this person penicillin, they're going to get hives. It's pretty intuitive. Now, a computer, unless it's got advanced natural language processing, might not know what to do with it. Is that penicillin-hives? Is it penicillin minus hives? What is that? How do I compute that? So for those what that means, we have the coded data behind the scenes. In this case, it is an allergy intolerance resource. You can tell that because the name of that resource is allergy intolerance at the very top. Next, we've got a code here, which in this case is the SNOMED code for allergy to penicillin. Okay, so we know it's an allergy intolerance, and we're talking about an allergy to penicillin here. We've also got down here the patient resource, so we can tell what patient this applies to. This is important because having that patient reference there means that we can actually safely extract this allergy intolerance resource from a document and process it separately. That was something you couldn't really do with CDA because everything was just this one big embedded XML file. But the fact that FHIR has resources and they're meant to be safely processable when you extract them is really important. So when I extract that from a document, I still have that reference to the patient. I know what patient we're talking about. And if there's any other resources that are referenced, they're there as well. Okay, but then the next important part here is over here under reaction, we have another SNOMED code there that is hives. And it's associated through that reaction and manifestation, those reaction and manifestation elements. So when you look at this, what you actually mean, what the computer can now understand is that the patient, Henry Levin, manifests hives as an allergic reaction to penicillin. Okay, and all that's now computable and done in a very standard format, and you can represent it in either XML or JSON or Turtle. Anybody use RDF or Turtle here? Good. Oh, you got to leave. Sorry. All right, so let's move on a little bit. Just talk a little bit more about bundle. So I described it quite a bit. As we said, that's the thing that's going to wrap the document and all the resources in it. There are a couple important parts about bundle that you need to understand when you're talking about documents. First, every bundle resource has a type field on it. There are, I think, about 8 or 9 different bundle types out there, but the one we're talking about here is going to be a type of document. When you do that, a few rules are applied. First of all, the first entry needs to be a composition resource when you've got a bundle of type document. Again, that document must be standalone, so you want to keep everything in it, all the references to all the resources in there. Also, there is an identifier on bundle, and that is supposed to be a unique identifier for this specific version of this specific document. Now, there's also an identifier on the composition resource itself. That's meant to be a version-independent identifier. But the idea is when you create a new version of a document, the composition resource identifier will stay the same, so that we can query and find, I want to find all versions of this document by its ID. But when you've got a specific version, you want it to have its own ID so you can tell that it is unique and isn't just going to be overwritten. Just important to have that up there. So referencing in bundles. So when you've got a bundle, you've got a series of entries in there, and that previous graphic I had just had arrows for the references, but this is the actual mechanism that you would use. You would have, for instance, a subject in the composition with a reference in it, and that will then contain a URI, Uniform Resource Identifier. And that URI can be in a variety of formats. In this case, I'm just using GUIDs to represent them, because you can represent GUIDs or UUIDs in using this syntax. And what you'll do is when you've got a reference here at one spot, it needs to match up to the full URL of another entry. And then FHIR knows what to do with these and can actually disassemble this and put them on a FHIR server, break this apart, and still keep all these references intact. These references can also be RESTful URLs. So if you want to pull a document or ask a FHIR server to assemble a document for you, it can do that, and it can keep in there as these full URLs, the actual full RESTful URLs. And then these references would just have, for instance, example.org/patient1. And this reference could either be that full URL or just a local reference, in other words, patient/1. And as long as the full URL up here has the FHIR server, it can figure out that that's a relative reference, and it would still work as well. So little bit of history on CDA and FHIR. So back when FHIR was first starting, around the time of FHIR DSTU1, so the really first version of it was actually balloted and reviewed widely and started to be implemented, a lot of the folks at HL7 that were interested in clinical documents took a look at it and said, is this actually going to work for documents? You know, FHIR had a document paradigm. We had to take a look at it and see, is this actually going to be something we can work with? So we did a big review of FHIR in order to answer the question, can FHIR handle the CDA use case? And to fix FHIR if the answer was no. So we did that review, and the answer was no. So we went in and we spent quite a few months there fixing up aspects of FHIR so that it could handle the CDA use case. So folks who are interested in sort of that history and the analysis that we did, if you want to go back, it's basically a spreadsheet, like a Google Doc spreadsheet, where we just kind of went through field by field in the CDA spec and made sure that we could actually represent it all in that generic fashion. Next, the Argonaut project came around. How many people, just show of hands, how many people know what the Argonaut project was? A fair number of folks, that's good. It's basically a project largely sponsored by EHR vendors. It was in response to what was called the JSON report. So the JSON report came out and said, we need something better than CDA. We need something that has APIs, tight coupling, uses modern syntax and standards, basically saying FHIR without saying FHIR. So the Argonaut project was launched to really sort of create FHIR as a next generation API for healthcare. But one of the early tasks under the Argonaut project was a comparison of Consolidated CDA to FHIR. And there were a few of us who worked on that, myself, Graham, Brett Marquardt, and a couple others. So fairly early, and what we did was we went down basically section by section in Consolidated CDA, and that's a 600-page document. So it was a lot of work going down section by section, field by field, template by template, and comparing them to FHIR resources. Again, with that goal, can we handle everything that's in Consolidated CDA, and if not, fix FHIR. So this is based on as we were approaching FHIR DSTU2. And the answer again was, it's close, but not quite there. There are a few major changes that we made. So we made those changes to the FHIR standard. And for historical purposes, people can go ahead and take a look at that. Again, this was largely an effort based on spreadsheets. It was analysis work. We weren't actually creating something that end users could pick up and implement yet. That was really the next phase of this project. So this is where we started the C-CDA on FHIR project. So this is a set of implementable profiles. The first release targeted FHIR STU3. We're actually working right now on a version for FHIR Release 4. We hope to have that out probably in the next month or so. But there is one published version out there right now that's official and ready for use. But again, it's on FHIR STU3. Most people seem to have implemented either on FHIR DSTU2 or are jumping to FHIR Release 4. So there was never a FHIR DSTU2 version of CC on FHIR, but we are hoping that the FHIR Release 4 one will see a large amount of uptake. For folks who aren't familiar, so FHIR implementation guides and profiles. Implementation guides in FHIR are collections of profiles, value sets, examples, and other resources, combined with human readable documentation in one package that describes what you're going to do for a given use case or set of use cases. And there's an implementation guide resource that ties it all together. And then there's this thing called the FHIR Implementation Guide Publisher, or IG Publisher as we call it, that you use to take all these computable artifacts, run a program on them, and it will generate HTML documentation as well as validation tooling and such from that single source. So FHIR implementation guide publishing is a fairly new and tricky process still. You'll hear a few sessions this week about creating FHIR implementation guides and profiles. Just be aware, whenever you talk about an implementation guide like C-CDA on FHIR or other IGs, they've gone through this process. So if you want to learn how to do that and be able to sort of contribute to the FHIR standard going forward, be very valuable to sit in one or two of those sessions. In this session here, we'll give an overview of one of the implementation guides, the C-CDA on FHIR one. So C-CDA on FHIR is a US realm implementation guide, so it is US specific. It uses the codes that are required to use under what was meaningful use, now promoting interoperability. It largely followed the Argonaut mappings, those analytical mappings that we did. And the goal was to create implementable FHIR profiles for the consolidated CDA use case. So we created a bunch of profiles on the composition resource and all their nested sections in there. For coded data, we decided we're not going to reinvent the wheel and try to do it all ourselves. Rather, there's a sister project going on called the US Core project, which creates profiles for the common clinical data set. We decided we'll just reference what that project is doing for how we're going to represent an allergy or a condition or whatever problem list. So that allowed us to get our work done very quickly. We focused on creating the document types, and we pointed to some to other work, parallel work that was going on for all the coded information. So if you're looking for C-CDA on FHIR, the easiest way to find the current published version is to just go to hl7.org/FHIR, so the FHIR homepage, and there's this area here that says implementation guides. If you scroll down towards the bottom, and there's a link that says published by HL7 affiliates and the FHIR Foundation. You click on that, and you will get to the FHIR implementation guide registry, and you'll see C-CDA on FHIR is, I think it's the third one down there. US Core will be the very first one that you'll see. You can also go to these direct URLs here. So this one is the current published specification, and this one is the current build, the one that we're working on right now. It has in it all the document types that are in Consolidated CDA, with one exception. You won't find one that says unstructured document. This is one that didn't see a lot of use initially, because meaningful use originally said, we're not going to allow that one. We're going to allow you to use any of these other document types because we want a lot of coded data sent. We don't want things like a scanned PDF with some minimal metadata. But that use case has actually seen a lot more importance lately because, having those unstructured notes is, they're probably about 80% of healthcare information, if not more, or in those unstructured notes without any coding with it. So that, in my opinion, was a pretty big mistake, and that's kind of been recognized now. So sharing unstructured clinical notes is now a core part of the US Core specification or implementation guide. So we didn't bother recreating that in C-CDA on FHIR because US Core already covered it, so we just point to it. But all these other document types, we've got composition resource profiles on them. So each one basically has the same sections that are present in the Consolidated CDA equivalent of them, and they define all the legal sections and what coded data you should represent in there. So US Core Framework, I've mentioned a few times. It's also available. You can go to that implementation guide registry or go to these direct links. The FHIR Release 4 version is, from what I understand, it's just waiting for Graham to finish his QA and hit the publish button. There are many other implementation guides like Consolidated CDA, the R4 version, that are waiting on this. So once that current build of US Core gets published, we expect to see a lot of other implementation guides coming out in rapid succession that all point to this and adopt it. And it basically has FHIR profiles for the common clinical data set. C-CDA on FHIR also defines a series of extensions. I won't go into this too much, but basically in FHIR we follow what's called the 80-20 rule, and anything that's not needed by 80% of implementation guide or implementations worldwide is usually pulled out of the core resources and rather used for extensions. Now, since FHIR documents are generic, they're not necessarily clinical documents, there are a lot of things that saw a medium amount of use, maybe under that 20%. That we decided not to make part of the core composition resource for that reason. But in C-CDA and FHIR, we created extensions for them, like the ability to capture who the transcriptionist was. If there's a performer that's performing a particular service. So these were created as extensions, and that way you can add those to any clinical document that you want. Right, now just to wrap up, I got a couple minutes left. I'll give a quick demonstration of the CCDA on FHIR spec. Here's the core composition resource in FHIR itself. The C-CDA on FHIR specification, the current published one that's on FHIR release or STU3 is available here. It is a little bit odd. It uses an older version of the implementation guide template that has this menu up at the top, which is actually references back to the core FHIR specification, and a lot of these links actually don't work since things moved around a little bit. But it's these subtabs underneath here which have all the profiles and terminology and stuff that are specific to this implementation guide. So you can then click on one of these and it'll actually bring up the profiles for FHIR STU3. And I hope my network is working. It says it's working. Let me skip over here actually and bring up this latest version. So this is the current build of C-CDA on FHIR for FHIR release 4. Very similarly, you can click on these at the top now, and instead of going back to the core FHIR spec, there are actually links that are specific to this implementation guide. And then you can scroll down here and see, oh, okay, there's a care plan document type. I can click on this and scroll down, and I can see some documentation about what the care plan document is. Click on this differential table, and then see the actual sections and such that were created. So a care plan contains a health concerns section, a goals section. The health concerns section has references to U.S. core allergy intolerance profiles, smoking status, vital signs, all the things that you sort of expect to be in that section of that clinical document. Now, there is one other interesting thing that I want is each of these document types builds on what's called the U.S. realm header. So this is a FHIR profile that sets the standard things that are present in all of the CCDA on FHIR documents. In other words, we reference all these extensions that are available that I mentioned on that previous page. Everyone will have a subject that is either a U.S. core patient or a group resource. If you have an encounter present, which is optional, it will be bound to the U.S. core encounter profile. So since this is in an inherited profile, it applies to all those document types. And one other thing that's interesting to note is once you've got one of these document types, so I just went back to the care plan document type. So if you want to see this differential table, we'll just show you the changes, but the snapshot table shows you the entire wrap-up of all these inheritance constraints, basically. It'll show the core composition resource, everything that's in the CCDA on FHIR US ROM header, and those sections that are specific to the care plan document type, like health concerns and such. Okay? And lastly, like I said, all these reference US core, so if I were to click on one of these, it's going to bring me back to the US core implementation guide, which looks, again, very similar, and I can see what a US core allergy and tolerance resource looks like very easily. Now, it might not have been very obvious, but I just skipped from one implementation guide to another there, showing basically that I'm reusing what's in US core. I'm not redefining or reinventing the wheel. So I think we're just about out of time here. Any questions before we move on? Yes, 1, 2.
Is there an easy way, or does a FHIR server handle going from a composition to a bundle, so automatically pulling the...
Yeah. I stripped those slides out because we only had 40 minutes, but there is it's called the document operation. So there's an operation that you can run on the composition resource that will do the bundling for you. Right now I know Gram server supports that. I don't believe Happy does yet. But it's a good thing to tap James Agnew on the shoulder and say, hey, why don't you do that for me? Okay. Emma?
I think my question is more about use case for C-CDA on FHIR. What are some of the use cases that you hear people intend to use C-CDA on FHIR?
Right. Well, I know it's in production use right now for pharmacist care plans. There's literally hundreds of thousands of those that have been created and shared. But that was, again, on FHIR STU3. There's also been a lot of interest from folks who want to use C-CDA on FHIR to comply with existing regulations, where they've got new developers that don't want to learn the old style XML from HL7 version 3, but they like FHIR, so they create FHIR documents and then they run a conversion to comply with existing regulations. So a FHIR to CDA conversion, and then are able to generate those. We do expect with FHIR Release 4 version of C-CDA on FHIR that that's going to explode. We expect to see basically all the same use cases that we see for Consolidated CDA to be used for FHIR as well.
What about C-CDA to FHIR
Yep, I've done that as well. So we did, for that pharmacist care plan and other implementation guides, we did bidirectional transforms. So folks with an existing CDA infrastructure could preserve and leverage that and convert to FHIR for those who don't have that, and vice versa. New implementers could just learn FHIR and then convert to CDA. Yes?
And so in line with that, there were some cases that couldn't be handled well, like negation. Was that dealt with?
Yeah, I find that's easier to do when you're going through specific profiles. I would say it hasn't been handled in the generic case, like can I negate any type of CDA template and do the equivalent in FHIR. Rather, what we do is on a template and profile basis, we would say, oh, here's how negation worked. You know, by negation, what we're saying is, you know, this person does not have this allergy. You know, if you want to do an assertion like that. So the way that's done in CDA and FHIR is slightly different. So on a case-by-case basis, you can do those fairly easily. But that sort of generic, all-encompassing, how do we do it in general, that hasn't been addressed. So I think we're just about out of time. I think it might be a little bit over. So if anybody has any final questions, I would say feel free to grab me in the hall. And Renee, I think you're up next, right? Is it?
Yeah, after the break.
After the break? Oh, okay. All right. So thank you all.